the insert interval problem. So given a set of non-overlapping intervals, you have to insert new interval and we need to merge if it's necessary. Okay, so the problem statements intervals, they're given 1 3 6 9 and new interval is 2 5. Okay, for this problem the main thing we need to do it is append the new interval and then sort it based on the start value. So that is one of the important things we need to do. And once we sort, we need to check if we can merge it. So for example, we have two scenarios here. The first scenario is we have a start time 1 4 and the second one is 3 7. So we already sorted it, and now we need to merge this. So in this scenario, what happens is you just need to compare the first interval end, which is the 4, with the 3. So if it is equal or less, if the second, the one which is interval, the second interval is 3 7, if 3 7 the start is less than the end which is before interval, then we need to merge it. So this would be like we would check the start of the second with the end of the first for merging. So that means it has to merge, and then we merge the end. So the end of first is 4 and the end of second interval is 7. So the whichever is greater, that would be the end of the new interval, the new merged interval. So the merged interval is 1 7. This is the one scenario, and we have another scenario here, which is the first interval is 1 4. So we have sorted it based on the first start alone. So always it should be 1 2. So that's how the sorting works, but we not sorted based on the ending. So what we need to do is, once we sorted from the first, we need to compare the second first with the first end, and if it is lesser than or greater, then we have to merge it. And then we have to also check whether the end of the second interval is lesser or greater. Based on that, our merge condition would be getting the end of the merged interval. So here what we do is, first interval is 1 4, second interval is 2 3. So obviously the merged interval has to be 1 4. So these are the two conditions which we need to evaluate before we understand how to do this problem. So one is sorting. So the algorithm would be, I just sort first. First I'll append the new interval, and I'll sort. I'll sort it based on start. Okay, based on start I'll sort it, and then what I can do is I will have a result array. So I'll have a result array with the first element added to it, and then we can iterate over the interval, and check for previous start, which previous element in result. So that would be the last element in result with the current element. Just check for last element with the current interval. So and you validate the start of the current interval with the last element of the first last element of the end, and then you can merge the intervals. So that would be the strategy. So first thing is, if there's no intervals given, so what we do is we will append the new interval, So new interval is this, and we'll return it because it's done. Else we will append, we'll start with this. We'll have a resultant array containing the first element. So we need to sort the intervals first. So that's the plan. So we'll sort it. Sorted intervals. And our key would be the first element. So if you want to know more about the sorted, I have one more video, so you can go through that. So you can easily understand the sorted keyword in Python. I've done one video on that, you can check that out. So here I would add intervals of 0 and then iterate from the first element. One, two length of intervals. So intervals is sorted, in result array is appended. So this is done. So now we need to check the current start and current end is nothing but your intervals I and 0 because it's another list, and similarly your end is nothing but 1. So start and end is I have 0 and I have 1, and your resultant, the previous element, the last element of result would be your previous start. So this is one we have to validate. It's nothing but your resultant last element, and the pre-start would be index 0 and pre-end would be index 1. Okay, so now based on the diagram, so we need to verify this would be a pre-start, this would be a current start. Check if the current start is lesser than or equal to pre-start, right? So that's the condition. If the start is less than or equal to previous start, then you have to merge. So you can pop this from result because we are going to merge it. And what would be a new start and what would be the new end, right? So new start would be your same, your new start would be your pre-start, so add that, right? And new end, what's new end? So new end is whichever of the end is greater. Is it max of pre-start and pre-end, right? So 4, 3, 4 is max, so you get max of pre-end and end, right? So that should give the then you append this new start and new end in the result, right? So that's what we're going to do. So this is your new start, that's a new interval, and that's a new end. Okay, if it is not, we're going to just add the array element. We'll add the current element in the interval, so that is intervals of I, and then we should be done. Let's run the code, check for any issues. Okay, it's done. Let's check the other conditions. Okay, let's check this out. We're ready for 8. Okay, let's check. 1 2 3 5 4 8. Okay, this is missing. Let's check why did we miss this. So new end this. Okay, let's print the result here. Okay, 1 2 3 5 4 8. 1 2 3 5. Start is less than or equal to pre-start. Sorry, pre-end, isn't it? So it should be pre-end. So that's the condition. So that works. Yeah, start should be pre-end. So that is what we need to verify. This is start, this is pre-end. So looks like this works. Let's submit it. Yeah, it's accepted. Okay, guys, thanks a lot. That was a mistake, but it's good to debug and get to the bottom of it. Thanks a lot. I'll see you guys sometime. Thanks.